The last lesson in Unit 2 is focusing on how to solve absolute value inequalities. In Lesson 5, we talked about how to solve absolute value equations. And if you remember, we always just um, dropped the absolute value signs and had two cases, one where we set it equal to a positive of the number on the right-hand side, and then the other where we set it equal to the negative of the number on the right-hand side. Inequalities are basically going to be the same idea. The only difference is when we set it to the opposite sign, we have to remember to flip the inequality because it's basically like thinking of it as dividing or multiplying by a negative, and whenever you divide or multiply by a negative, you have to flip the sign for an inequality. So you're going to do the same thing, always isolate your inequality or your absolute value bars first, and then you're going to have the same case, so you're just going to drop the absolute value bars, so you have 2x minus 5 is less than 3. And then you're going to have the opposite case, which is where you're flipping the sign. So this is where you're going to have 2x minus 5 and then is greater than negative 3. So I flip and negate for this. So negative 3, and then you flip the sign because you made it negative. And then you just go through and you just solve these as normal inequalities. So the only new thing is just this initial setup. So add 5 to both sides over here. So we have 2x is less than 8. Divide everything by 2. So we get x is less than 4. And then over here, we have add 5 to both sides. So 2x is greater than 2. Divide everything by 2. We get x is greater than 1. So basically, you just have to remember when you're solving the inequality steps, it's just like solving the equation. The only difference is if you divide or multiply by a negative, you have to remember to flip the sign. So to write this as one entire solution, we would put it on a number line first. So let's see what it looks like. So I have the point 1 and 4. I'm going to have open circles at both of those numbers. And I'm looking at x is less than 4, which means I would start at 4 and I would shade to the left, as well as x is greater than 1. So that would go this way. So where both of these overlap, because these both need to be true, is in the middle. So my solution is 1 through 4, or 1 going to 4. So I can just write that down here. So the solution is 1 open bracket 4 open bracket, because again I'm not including 1 and 4, so we use the round brackets versus the square brackets if we had a solid point at 1 or 4. Basically another way to think of this is, yes, it is an and solution, meaning you can have numbers that satisfy both of these conditions at the same time, and they would have to be between 1 and 4. So if you wanted to leave it as inequalities, your solution, you have to make sure you put the word and between them, because it's what's satisfying both of these. So let's look at another example. So this example here, we have again the same case, and then we have the opposite case. So for the same case, keep everything the same, making sure that that absolute value is isolated first. Opposite case, we keep the absolute value, the part under the absolute value the same, flip the sign, and then negate the number at the end. And then you just solve them as normal. So we get x is greater than 5. And then for the opposite case, subtract 2 from both sides. We get x is less than negative 9. And then we go ahead and we graph these. So we have negative 9 down here and 5 over on the right. We're going to have, again, open circles on both of these because it's just strictly greater than 5 and strictly less than negative 9. So you look at your shading. So for x is greater than 5, well, it would be an open circle, and it would be shading to the right. You got to think of it, okay, the inequality sign is pointing to the right, or x is the bigger thing, so I'm going to the right. If I go over to the x is less than -9, that means I'll be shading on the left. So if you started here, you'd be shading on the left. And this means this is an OR situation. When you shade on the outsides, it's an OR situation, because I can't have both of these inequalities true at the same time. So my shading doesn't ever overlap, where in the previous example, my shading overlapped. So that shows me that it's an AND situation, and I shade where my inequalities, my individual inequality solutions overlap. Meaning I could, if I was the number 2, I would be satisfying both of these inequalities at the same time. Where over here, you can't satisfy both inequalities at the same time, so the word that you would have to put between these would be OR. So if I'm up at 6, yes, I'm greater than 5, but I'm not less than -9. So that's why this is an OR, where the other one was an AND. And you can also look at the original. So this was a less than 3, where this was a greater than 7. So that kind of shows you if it's originally a less than, it's going to end up being an AND, where if it's originally a greater than, it'll end up being an OR. So that's another rule to kind of go by as well. But you can really just kind of graph it and see what you get. So in interval notation, if I wanted to write my solution, I have -infinity. We always do open brackets at -infinity to -9, and a round bracket or open bracket at -9 because I'm not including it. Since it's an OR, we're going to do the union symbol. And then 5 going to positive infinity. So that's just another way to write it. So let's look at a couple more examples, and then that's really it for this lesson. So let's look at just a couple more. So here's an example where the absolute value is not already by itself. So what we want to do is we always want to, before you break it up into your two cases, you always got to get the absolute value by itself. So first thing I need to do, 2x plus 5 is greater than 11. So always get the absolute value by itself. And now that I have the absolute value by itself, I can break it up into my two cases. So remember, we have the same case, and then we have the opposite, where we flip the sign and we negate the number at the end. So the same case is going to be 2x plus 5 is greater than 11, keeping everything the same. The opposite case, 2x plus 5 is less than, negate the 11. And then just go ahead and solve your inequalities as normal. So subtract 5 from both sides. So we have 2x greater than 6. Divide everything by 2. So x is greater than 3. Over here, we subtract 5 from both sides. So we have 2x is less than -16. Divide everything by a 2. So we have x is less than -8. One thing I want to point out, when you are dividing by a positive, even though I took -16 and divided by a positive, notice I didn't flip my sign. You only flip your sign if the number in the denominator is the negative, meaning you're actually dividing by the negative, or you're multiplying by the negative. So if you start with a negative number, that -16 doesn't affect the rule. So it's just if you're dividing or multiplying by a negative. So we get our two solutions, and we're expecting this to be an OR situation because of how we started. The absolute value was greater than, we had the greater than symbol. But just to kind of, make sure, it's always good to graph and take a look. So we have -8 and 3 on our number lines. We're going to have open circles at both of those. And again, since I'm expecting it's an OR, I don't really need to graph above. I can kind of just do it in my head. So x is greater than 3 means I'm going to be going to the right for 3. And since x is less than -8 means I'll be going to the left. So I already expected an OR, so I didn't really need to graph and see if there was any overlap. And since there's not any overlap, this is going to be an OR situation. So your solutions would be x is greater than 3 or x is less than -8. Looking at it on a number line can help us write it in interval notation. So in interval notation, negative infinity to -8. Notice I'm doing open brackets around all of them because I'm not including it. We never include infinity, we only approach it, so that's why infinity is always open brackets. And then 3 to positive infinity. So that would be your solution for that one. And then the last two examples here I want to show you are really just like special case examples where I just want to kind of make you aware of what's happening. So if you look, this example here is saying that the absolute value is less than a negative number. And we know that this can never happen because if you think about absolute values, if you take the absolute value of -5, you get +5. You take the absolute value of a positive number, it's going to stay positive. If you take the absolute value of a negative, it's going to stay positive. If you take the absolute value of 0, you're going to get 0. So there's no way that you could ever take the absolute value and get a negative number, which means the absolute value of something could never actually be less than a negative number. So this can never happen. You can never have an absolute value that's less than a negative number or less than 0. So this can never happen. And that's because absolute values are always going to be positive numbers or 0. So absolute values are always positive or 0. So you can never, an absolute value can never be less than 0. So absolute values are never less than 0. Which means they could never be a negative number. So just like those examples where we had in the equation section, absolute value equal to 0, that has no solution because you can, or absolute value equal to a negative can never happen because you can't be anything less than 0. If you look here, absolute value can never be, even if this was a 0, that couldn't be the case because absolute values can never be less than 0, meaning they can never also be less than a negative number. So the answer to this question is just no solution. But what if you didn't notice that and you actually went through and you did all the work? Well, this is where you would do the work and then you would want to check your answers. Meaning all of these previous examples, you should really be checking your answers. So you should really be taking those numbers in and plugging them in and see if it actually works. So if I have, going back to this previous example, x is greater than 3, I'm saying that that's a solution. So that means if I pick any number bigger than 3, it should work in my my original inequality. So if I picked 4 and I plug it in, I would have 2 times 4 gives me 8, plus 5 gives me 13, 13 minus 2 gives me 11, which is bigger than 9. So it should always be working out if you pick some value. That's kind of how you check your solutions. And so it's always a good habit to get into because there's some times where you're going to get no solution. So you just kind of either be aware of the situations that create no solution or just always remember to check your answers. So let me show you one other situation. So this example here, if you actually went to solve it, you would see that your solution is going to be always true. But the shortcut to this is if I look at this, we're saying that the absolute value is greater than or equal to a negative number. This is always going to be the case because absolute values are always equal to 0 or they're going to be positive. So even if this said 0, it would still be the case because the smallest an absolute value could ever come out to be is 0. Otherwise, it's going to be positive, basically what we just said. So this is always going to be true. So it's the complete opposite of what we were just looking at. Always true because absolute values equal 0 or are greater than 0. Which means that if you have a negative number, it's always going to be greater than or equal to that negative number. So you can never actually get out a negative absolute value, so it's always bigger than it. So the solution for this one is just all real numbers. This is always the case.